All right, so later in this unit, we kind of looked at some perspectives of graphing proportional relationships. And that shouldn't necessarily be a foreign concept, since when we were in the beginning of the school year, we went over graphing on charts. X and Y data, we did the same thing in coordinate planes. So we're going to look at this and talk about this example of like cups of sugar to cups of flour. I think it's a great comparison. So when we look at this here, we tell ourselves, okay, well, how do I graph this proportional relationship? Well, the first thing I have to understand is that whenever I have a relationship between two things, a ratio, it is always one thing compared to the other. We talked about how in ratios we have A to B, and we have it in different forms, but here we're gonna have X to Y. All right, so the first thing I obviously need is to see that I'm missing parts on this chart. I have to figure out where these things go, okay? So, looking at this, let's say, I have, for every 2 cups of sugar, I have 1 cup of flour. All right, well, I can see that that's a multiplicative relationship there of how do I get from 2 or 1 to 2? Well, I have to multiply by 2. All right, well, let's see. If I go here, do I do the same thing? Well, what's 6 divided by 2? Because since I don't have the number here to figure out my multiplicative relationship, I do the inverse function, which would be division. So I say 6 divided by 2 is 3. All right. All right, so if this is 6 divided by 2 is 3, okay, so 8 divided by 2 is 4. All right, since I'm going this way for division, I'm going to try the opposite way. So I have here, I have 5 times 2 is 10. Right? And we'll say this right here. Now, as a reminder, the pattern going this way across just cups of sugar or the pattern going this way across just cups of flour does not matter at all. Doesn't have to be consistent of a pattern. It could make jumps in the data as long as our multiplicative relationship is always the same. All right, so let's take a look at how to graph this on the chart. All right, so I see that I've already set up my grid. All right, now say 1, 2, 4, 5, 6, 7, 8, 9, 10. Go up the side here. 1, 2, 3, 4, 5, 6, 7, 8. All right, now, just because I ran out of space here, doesn't really matter on this grid unless they already present the data to you on a grid that you already see. Since I only have enough values here for this, I'm gonna flip it right quick just for the sake. Everything is okay. Don't panic. All right, so let's look at this data right here. All right, so my first point is 2, 1, okay? 2 is my X value, okay, 2, and then 1. First point, okay, let's use a brighter color. A little better. All right, next point is 4, 2. 1, 2, 3, 4, 1, 2. Next point is 6, 3. Then 8, 4. And then 10, 5. All right, now, when we discuss this, there was a very, very, very important rule that we have to follow. Is rule number 1, okay, is for everything to be a proportional relationship, for this to indeed be a proportional relationship, we have to have a consistent multiplicative relationship. So this to this, this to this, this to this, times 2, times 2, times 2, times 2, times 2. All right, now numbers 2 and 3 rely on looking at our graph, okay? We'll say graph. All right, 2 rules about looking at our graph. So the first rule, line must be straight. Rule number 3 here is line must pass through the origin. All right, now, as you can see, I've plotted my points here, got a ruler, and I want to line up my ruler on all of these points right here, okay? Right at where it meets the exact point, all right? So I see that right there. I'm gonna draw my line all the way through each of my points, all right? Now, looking at this right here, is this line straight? Yes. Is this line going through the origin? 0, 0. Yes. Do I have a consistent multiplicative relationship? Yes. All right, then this is proportional. All right? Now, I want to take a second to look at how I'd represent this right here in more of a different manner, because I can see right here that if I was trying to fill in this data, that I need to find out some other way if I don't understand like the multiplicative relationship. All right, so piece of paper here. Now, when we first started this graph right here, okay, I had my 1, my 6, my 8, and my 5. All right? Now, generally, I should have something to compare it to here. All right, so let's say 3, 6. So I'm saying cups of flour, 2 cups of sugar. All right, so let's draw this as a model. Let's say, I want to say that my cups of flour are going to be, I think it's maybe magenta, I don't know. We're going to call it magenta. And then we're going to say my cups of sugar is teal, whatever color that is. All right, so I know that I have 6 cups of flour. So let's do that. 6, 2, 3, 4, 5, 6. Now, for that 6, I have 1, 2, 3. All right, so for this 6, I have 3. This gives us an interesting look because when I draw this out, I know that I can see that I can group that together of 1 to 2. Group this together of a 1 to 2. Group this together of a 1 to 2. So I can see my relationship here. So I put 1 over 2, right? What is 1? 1 equals 2. There's 1 cup of sugar to 2 cups of flour. All right, now let's look at this one right here. How do I get this value if I'm following the same process? Well, I know I have 4 cups of flour and 2 cups of sugar. Well, if I look here and I say, well, what do I have if I have 2 cups of sugar? If this is 3 and this is 1, okay, so between those 2 would be 2. So what do I do with that? All right, so let's see. I'm gonna say 1 cup of sugar, 2 cups of sugar, and every single one that I have will have 2 cups of flour. So then I pair those together. All right. I group them together, and I see that 1, 2, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4, 5, 6. Same if you keep going with the same pattern. We say 4 cups of sugar. All right, 1, 2, 3, 4. Every cup of sugar is going to have 2 cups of flour. 1, 2, 3, 4, 5, 6, 7, 8. Group them together. 1, 2, 3, 4. All right, so that is how I'd look at modeling if I was trying to get my rest of my numbers from the chart and you didn't want to think about doing the multiplication or the computational part. You could set it up as a model. It's perfectly fine and super helpful in times of need. All right, awesome.